Thank you for joining us today on Innovative Training Revolution, Immersive Learning and on-the-job training. First of all, I would like to thank you all for having you all today, notably our speakers for accepting our invitation. My name is Olga Hunchak, Policy and Project Officer at SESIMO, the European Association for the machine tool industries and related manufacturing technologies. I'm going to be the moderator of today's webinar that SESIMO is organizing. So let me just quickly share with you the screen and I will quickly present you SESIMO. Okay, you can see it, perfect. So, SESIMO is the European Association of Machine Tool Industries and Related Manufacturing Technologies. It has 50 national associations across Europe, which consist of more than 1,500 industrial enterprises, and more than 80% of them are SMEs. So SESIMO provides market intelligence service for the machine tool sector by gathering, analyzing data, and providing input for our members on the evolution of the global markets. SESIMO also promotes the machine tool sector through the EMO exhibitions. EMO is the World Trade Fair on machine tools and metalworking. During EMO exhibitions, many industrial sectors gather, such as from the machinery sector, automotive sector, aerospace, shipbuilding, etc. EMO exhibitions happen every 2 years, either Milano or Hanover. This year we're going to have it in Hanover, and we will organize also some workshops focused on skills and training. In order to bridge this skills gap. SESIMO also participates in the EU-funded projects. Currently, we are involved in 5 projects. 2 of them are dedicated to skills development, such as STEM, which is the project focused on the additive manufacturing skills, and also the green project that we just started, it focused on the development of the green skills. SESIMO also organizes events, conferences, webinars, events in the European Parliament relevant for our sector. SESIMO as well contributes to the development of interest of our members. We are involved in the EU policy making, in the agenda setting, as well as in the policy implementation. And we work on policies such as sustainability, circular economy, digitization, artificial intelligence, robotics, trade, internal market, competitiveness, and skills development. Speaking of which, this is why today we have this webinar. So given that digital transformation and life learning are now in the center, and this year is going to be the year of European skills, this is why we're organizing today's webinar, in order to bridge this skills gap between the needed skills and the professional profiles. So the webinar intends to raise awareness on innovative training practices for optimization of new technologies, and also to encourage companies and other organizations to apply the extended reality training and on-the-job training in their everyday life. So today with us, we're going to have 3 speakers. Mr. Thomas Schneider, who is Managing Director of Research and Development at Trumpf, the machine industry company, and he's going to present New Learn and Application Center at the KIT. Our second speaker is going to be Silvia Giordano, who is professor and head of the Trustworthy and Security Group, SUPS University of Applied Sciences, and is going to present the virtual reality for manufacturing, how to improve the use of complex and dangerous machinery for the workers in the manufacturing industry of the future. And last but not least, we're going to have Yannick Rosmeyer, the PhD student and research assistant at the Darmstadt University of Technology, who is going to present a cognitive assistance system for work integrated learning and the implementation of machine learning applications on the shop floor. So now I will pass the floor to Mr. Thomas Schneider to present.
Good morning.
Good morning.
So should I share the slides or?
Yes, please.
Okay. Yeah. So good morning, everybody. So I'm really happy to present here in this webinar the first ideas of how we think as a machine tool builder we would like to invite in the community an approach of a different learning, and we have it started in the University of Karlsruhe together with the Professor Sven Mattesen, and we have also we have been glad to give an article in the last fall Sesimo magazine. So that is the first invitation. So if I'm too fast, then please contact us. Our address details are there, and some more ideas. So what is it behind, and what was the validation we also did, and why we think that this is the next level of education, as well as for students, but also for us as a company to reskill and upskill our people. And I would like to give you a first view on the what we have done in the last months. And this is in a short video. I hope this works for you. Is the screen moving?
Yes, it works.
So what do you see here is students producing a design of a systems engineering approach, including different technologies, different skills in programming, CAM, wood, sheet metal, then test their own equipment, improve it, produce it again, and finally go into a competition and see who has the better solution for the question. So, and what the KIT has decided together with the government of Baden-Württemberg is that they would like to invest into a new infrastructure, and they have been looking for a partner, industrial partner, and Trumpf from our side, we have a strong interest in getting sheet metal more into the next generation of design engineers. So we decided to join this joint journey of reskilling, upskilling, and bringing new technologies to students and our people, because we think we could also train with our engineers in the same site. So that is the key idea now, is for us to set this up as a real laboratory. We call it Learn and LATS, Learn and Application Center at the KIT. And we would like to bring students to a real industrial problem, solve it, and reflect it, think about it, transfer the knowledge. So it's a circular economy within design. And it's the core belief is the learning of students gets better if they also fail fast during their studies. So it is a secured environment. They can do with industrial tools more or less simple systems engineering questions, but industrialized, produced, then tested, validated, and they understood where they fail. So it's planning for failure is one of the key ideas, but having success at the end. It should take half a year. It's a part of the curriculum, and we would give all over 10 years. That is a commitment from TRUMPF with the KIT. Every year, 2 questions which are linked to our customers. And on parallel of that, or a core element of this transformation journey is that we would like to assist the students in their development of the solution with a learning catalog. So we go through them with a simplified process on production. We assist them, you should design it like this, and it is better produced. And so both sides, and that is the interest for the industry, is we get better understanding the front users of our production technology, which is the design engineer, where we have, as of today, normally not a connect. The design engineer designs, but he has only an experienced idea of which production technology he should use. And if he has never used sheet metal before, he will never decide that it is good for sheet metal. So that is, I would say, the idea behind this. And so how we do, we give a real challenge from one of our customers. We put some systems engineering around so that the students get something with, you have seen, wood, wheels, Mindstorm, so it's software included. So it's that it is a system, but in between there's a challenge, a design challenge of a simple sheet metal part. They train it, they produce it, and our customers are getting back, or 2 customers of us get back an answer of how the solution on the sheet metal could look like. So this is the idea and the TRUMPF perspective. Why are we now at CETSIMO in this webinar? We think this could be generic, and that is the idea of why we have chosen the university, and it's part of the contract that we would like to franchise it without costs. The only cost which the KIT and the colleagues will take is that you have to share your data. So we will build up an open platform where all of us, or the companies who are interested in with different technologies at different sites, are interested in taking part in this journey for the price of sharing the data. EU conform, Gaia X conform for sure, all the things which we think is important in the future. But then it is a data-based learning environment, including different technologies, being international, connecting labs across the world. So that is, in principle, I would say, the idea why we presented in this webinar. So there are 2 things in. First is getting iAssist learning catalog on specific production technologies. On our case, it's sheet metal, because we are passionate about this technology. And the second is get connected in the world. And in the first step, it's the EU. And we would like to invite all the partners. And it's myself from TRUMPF being the CTO, and Sven Mattesen, who is the head of the IPAC at the KIT.
All right. Thank you very much, Mr. Thomas Schneider, for your very insightful presentation about the training program for workers and students. So, all right, I think, so unfortunately, Mr. Thomas Schneider will have to leave us now. So will not be able to join us for the Q&A session. So thanks again for your very insightful presentation.
Thank you very much. And just to make some advertisement for this very good CETSIMO magazine in fall, if you find the article in there, you can find my email address and the email address from Sven Mattesen. So sorry for not being there in the Q&A session, but we are willing to answer every question by mail or set up a session. So it is for us the invitation to come and see. The first students group will start mid of this year again. So maybe just have a look how the students are working on it. And secondly, to get the opportunity we would like to make it an open, transferred and scalable learning community within the machinery tools business. So that is the idea, and everybody who wants to join, please just feel free and connect, and then we answer all other additional questions. So thank you very much for getting the opportunity, and all of you a very good webinar.
Thank you, Lutz. Thank you for joining us. All right, so now I will pass the floor to Ms. Silvia Giordano. The floor is yours.
Sorry, I had to unmute myself. So thank you very much. And what I'm going to present here is the usage of virtual reality, in particular for manufacturing, for training and learning in manufacturing. But actually, we are doing this for several other areas. And in particular, we started with the idea on how to improve the use of complex, dangerous, and very expensive machinery that are traditionally used in manufacturing. And this is a project that is has been developed, activity that has been developed under the AT manufacturing, two projects, Virtual Machina, vMachina, and Winning, but also is part of a Horizon Europe project called XR to Learn that just started. So basically what we have is that there is a huge gap between traditional and the future industry, because the current manufacturing industry, and in particular the SMEs, are barely digitalized. So this is a contradiction, especially because the digitalization is necessary for the usage and maintenance of expensive, dangerous machinery, and their use is also quite difficult. So people that has to move toward the usage of new machinery have difficulties. I mean, the training is not that easy. And also there was a side effect of pandemic, because people during pandemic were blocked for their collaborative activity or practical experiences. And all these type of activities have moved on a digital world, where you don't have exactly the same environment. Even if you have it from the communication standpoint, you miss several points that we are going to see in a short while. So in the vMachina project under ATM, we started to think that we wanted to create a collaborative environment to be able to respond to the challenges that we described, and also overcome all the limitations of pure digital collaboration. In that sense, also, we aim to increase resilience of stakeholders in case of pandemic, and also to have a new future where we have more collaboration, even if this is done digital, so reducing the number of travels and commuting. And above all, we wanted to put the human at the center of this human-machine collaboration. And the idea to use virtual reality as mitigation was to say that practical activities, collaborative work especially, can be also performed remotely using virtual reality, and in particular with the virtual reality digital twins of the machinery, where workers can interact and select equipment, machinery, etc., simply using virtual reality headsets, where multiple users can work together, and also thinking on the fact that technology, the virtual reality technology, is sufficient for having a real deployment of virtual reality-based solutions. And the other very important advancement, especially from the teaching standpoint, is the fact that activities in the virtual environment can be easily monitored and can be done an analysis of them that allows to judge or understand the value of the work done by some worker or by some student, but can also include something that is really missing in the digitalization world, that is emotion, fatigue, stress, and other psychophysical aspects that are relevant or fundamental to have a real digital interaction between human and machinery. And here you have an example. I cannot go too much in details, but what we do have is this virtual reality element, manufacturing environment at the bottom, with all the modules, for example, modules for gamification or for the user avatar, but in particular, as I was telling before, the human emotion recognition module. And you have several modules for machinery that are using the elements below, like a Lego, to be built. And we have done 4 machinery as an example in our projects, but you can do whatever type of machinery. And then on top of that, you create the learning modules that are the courses that are online and that can be accessed by simply using the virtual reality instrument and play on the machinery that has been designed on virtual reality environment. And from them, you can extract the user experience and use a traditional user feedback to understand whether the user has learned and had a good experience with this learning, but also you can capture the experience in an automatic and more objective way, thanks to the virtual reality positioning system, and therefore adapt the system directly for the user. And okay, this is also. So in the module, people are represented with the avatars, and their physical characteristics are reported not for having something that can be privacy breaking, but rather to have something that is really adapting to the user. For example, a tall students compared to a not tall student can have a different interaction with the machinery. And actually this allowed us to have to foster several paradigms. The first of all is working for all, because as I said, this environment that we created is a sort of Lego where everybody or about everybody can take pieces and put them together and create any model of machinery. And then the access for all, that means that everybody can have a tailored experience on this machinery without any discrimination. And in fact, we use that also for a project that is specifically targeting women in manufacturing. And then the feeling for all, because as I said, the emotion has been included in the human-machine interaction, creating a really unprecedented virtual experience. Then this was also creating some side effects like democratization of the virtual reality simulation, resilient machinery usage, also a simple simple way to evaluate adoption of a machinery, like instead of having to buy or rent a machinery to test it within a company, we can directly do this with virtual reality. Of course, as I said, we have this tailored experience without any type of discrimination. And this is also important for managers in some way, because sometimes when you, for example, apply for a job and are asked to do a task, the manager who is judging you is somehow biased by the video, by the fact that the person is seen. For example, it's reported in some analysis that women are score lower compared to men when they do a manufacturing task. So in this case, as avatars are used, you are blind for managers, and therefore you are evaluated with more objectivity. And also, as I said, there is this activity recognition and emotion recognition that are going to put technology more close to the users. So I had to go very, very quick on this, but clearly you can get much more videos and elements of these activities on the Virtual Machina website. That is this one that I'm pointing. You can send an email to me. And also I encourage you to follow the activities of this new project XR to Learn that just started, where we are going to improve this emotion-based part in order to create really a complete, personalized and feedback-based, adaptive-based solution for students and for trainers. And that's it for me.
All right. Thank you very much for your very interesting presentation. I think we learned a lot about how to improve complex and dangerous machinery for the future industry, especially by putting the human in the center with the virtual reality applications. Thank you again. And now I will pass the floor to Mr. Rosemeyer. The floor is yours.
Thank you very much. All right. I want to present you something completely different. Something for indeed on-the-job training. So what we saw before was ideas that could be used outside of actual work, but the idea that I'm going to present you in a second is meant for learning directly in the process of working, or rather even more, some way more in the at the workplace itself. So when we have a look in strategic agendas of manufacturing companies, we often see something like Industry 4.0 is at our core, or we have a strong agenda, or whatsoever. And indeed, many manufacturing companies put emphasis on Industry 4.0 and on Industry 4.0 solutions. But what also can be outlined, or can be identified, is that the actual user, or the people themselves, remain at the center of manufacturing, or on the shop floor, which somehow displays a contradiction. But when we talk more about Industry 4.0, we also see that more data is generated, which leads to the problem that much data also has to be analyzed. And in literature, theoretically, we can see that machine learning applications get high advantages when it comes to data analysis, in fact. But On the other hand, whereas large companies also profit from machine learning applications, it completely looks different in SMEs. They rather have a lack of competencies, they have a lack of infrastructure, and also they have a lack of data, which might be generated by Industry 4.0. So the question is, the problem is when companies want to use machine learning or Industry 4.0, they have to somehow deal with the prerequisites, more or less. I don't want to go too much into detail with infrastructure and data, but I want to stick at the person or at the workers and shop floor managers themselves, because what we can identify also is different competencies in times of digitalization. So whereas information knowledge was more important in the past, the action knowledge and how to deal with applications data becomes much more important. And also we can see that problem solving, which is much more important in the future for people, cannot be gathered outside of the production or outside of the job, but rather within the job. When we have a look in literature how to identify or how to train problem solving skills, this can be, for example, be done by vocational or by work integrated learning. But the question is, how can work integrated learning be realized? This is where my idea, or the idea that I want to present you in this presentation comes into play, because many literature or many authors say that so-called cognitive assistance systems can yield high advantages and can also be a possible medium, which is why I want to present you a cognitive assistance system that can be used in manufacturing environments for training the basics of machine learning, and also then applying first machine learning use case. So in fact, the idea is to develop a software-based cognitive assistance systems that can be used during first steps when implementing machine learning applications, which also allows to enable competence for machine learning in a work integrated learning manner. And thereby we also, or the idea also addresses obstacles that can be observed when implementing AI or implementing machine learning, which, for example, are structured project management. Yeah, and the idea is to focus on production managers and team leaders with decision-making competence. Before presenting some insights into the software, I know that I am on a very high level by now. I want to have a look at what others actually said that use the software. So we tested that with users from lower management, and they say that on the one hand it was useful for their work, it increased the work performance, and it also facilitated their work, but it still has some problems with the operations. For example, some first insights and also guidance through the software is needed, and also it lacks in terms of customization. You can already see some images below, but I want to have a closer look into the software now. So what we did is we used this so-called data mining methodology for engineering applications, which you can see on the right-hand side. And the software then guides the users through these single steps by asking questions, by providing information, and also by providing tips And also, this is not displayed in this presentation today, by also providing background knowledge. So first it starts with business understanding for indicating the actual use case, for example, here predictive maintenance, by also then asking relevant KPIs, by asking for required data, and the idea is if not yet implemented, users can or ask to adjust and to ensure that the respective systems are then realized. Very important in this term is also data understanding and data competence, which is why users are asked to, on the one hand, first play with data and make themselves familiar with data, and then manipulate the data in the second step. The actual modeling step, where the use case or where the machine learning model is trained, is very small part. So basic or the overall emphasis is laid on other steps than actually the modeling, to ensure that also SMEs can implement the actual prerequisites. Finally, the modeling is only a little step. Okay, what have we learned? Actual or existing training formats, for example, seminars, are no longer applicable when it comes to machine learning. Rather, on-the-job training or actually work integrated learning is necessary for machine learning, and cognitive assistance systems can be one medium that is helpful for ensuring work integrated learning. And finally, it's especially important to teach also domain experts, for example, production managers, and not only IT specialists with the fundamentals of machine learning. At this point, I want to thank you for your attention. I hope you have a good day. And if you are interested in more detailed information, please feel free to drop me an email. You can see my email address at the lower right side. And at this stage, I want to go, or I go back and give back to the secretary. Thank you very much.
Thank you, Mr. Rosmer, for this presentation. It was very insightful to learn about the cognitive assistance systems in implementing the machine learning in manufacturing environments. So now I believe we can start with the QA session. Ms. Giordano, I would like to ask you a question. What could be the role of education system to foster the virtual reality training, and what are the challenges to virtual reality trainings development?
Okay, I have to say that we are not working without the support of our education department in doing that, because if you want to use technology for education, you actually need to do it in a way that is also aligned with the current education trends. For example, one of the elements that is very relevant of virtual reality is the fact that right now education is moving forward competencies, no more using the, let's say, the final result of some activity, but trying to understand if the student or the trainer had the right competences to do a task. And actually, even in a classroom, in a traditional classroom, this is very, very difficult to be followed, because you need to follow many students, and actually the teacher has no time to do it. While using virtual reality, and especially using some, let's say, digital milestones in the virtual reality capturing, you can understand whether this is done in an automatic way, and let's say analyze the competences of the student with the support of machinery, of technology. That means I think you cannot do digitalization for learning, for education, without doing, without the competences of educational scientists and researchers. So I think it's really fundamental.
Yes, of course. Well, thank you for answering this question. Then I would like to ask a question to Mr. Vosmeyer. How do you see from your perspective, how do you see the on-the-job training happening in 5 to 10 years from now? And do you think that the certification of skills will be valued in the workplace?
First of all, I am of the opinion that we see an increasing number of opportunities for on-the-job training. I mean, we can see this already now compared to like 5 or 10 years ago. So first of all, the increasing number or increasing possibilities, which also leads me to the fact that we still need more mediums for work integrated or for on-the-job training, because when we have a look in literature, we see little opportunities. Whether it comes to certification, well, that's a good question, and that very much depends on us on the one hand, and it also depends on HR departments or companies themselves, because there's still contradiction between learning and working. Whether we will be certified, that's a good question.
Can I add one thing?
Of course.
If possible. One important element of using technologies and virtual reality is also the fact that, is also the fact that you can have learning also for people, for example, for third countries, or people that are not in a position to really get easily this type of education. And therefore, I think, I mean, that technologies is also a sort of bridge to other countries, to other people that are not in the right position. So in that sense, is really democratic.
One aspect just comes into my mind. We see a time of more and more flexibility for working on the job. We also see an increasing, or we see more demand for flexibility also on our side, on side of on employees, for example, in terms of with easy facts like parenting, like going to the doctor and whatsoever, which also requires more flexibility for employers. When I think that, or I don't see the problem, for example, for more learning on the job in times of flexibility, because we have the flexibility in any way.
Oh, of course, yes. Well, thank you very much for both of you for answering this question. And yes, definitely the education system and the industries, they should go hand in hand together. They should cooperate for better training and skills development of the employees and students. So my second question would be perhaps to Ms. Giordano, are the virtual reality devices, are they suitable for any kind of training, or they must be quite specific for?
Okay, I will say that they are usable for any type of training, but actually there are, for example, we are trying to use them also for very specific classroom tasks, like physics, for example. And there are some difficulties that are virtual reality difficulties, like every time you use some fluidodynamic element in the story with virtual reality, you can hardly represent it at the moment. Clearly, I do expect that in 5 years, this will be a known problem. But at the moment, while you can, for example, show to students something fantastic like walking on the moon or walking on Mars, because this is something that can be reproduced in virtual reality. And this is something that can add to traditional teaching, because it's something that clearly you cannot do in a lab. On the other side, it's very complex to do a chemical experiment where you mix some chemical elements, because the chemical reaction is not easily representable in virtual reality at the moment, as I said. But for example, you can let them play with fire in virtual reality, because this is not dangerous. While I mean, I say fire, but whatever is dangerous, because in virtual reality, you can have an alarm when it is dangerous, but you don't get hurted. So that's really a huge advantage of virtual reality.
Exactly. This is the beauty, actually, of this new technology of virtual reality for training, for this safe training, because employees, they don't have to be exposed to any kind of danger. So they can be just in simulated environments and perform the training much safer. Well, thank you very much for answering the question. And I'd also like to ask another question to Mr. Rosmeyer. How to increase the chance for employees to get a better access to training and reduce the perception that some training could lead to less productive hours, like to lose the productive hours?
Mm-hmm. Well, basically, what we need is more opportunities. We still have little opportunities that can be used for learning on the job. I mean, learning basically is still outside of job. Also, I mean, outside of the workplace itself, actually. So very much still in seminaries with little connection to the job itself. So what we need, first of all, then, is more opportunities. This can either be done by more practical examples, or it can also be by digital mediums, where learners can consume some content, for example, in half an hour, in between two meetings, or at the end of a working day. But what we also need is a change of mindset, that learning also hinders from working. The learning always hinders from achieving productivity. First of all, that leads, or it reminds me of a situation that okay, now I get stuck. Okay, forget what I just said. What I just started. Yeah, that's actually it.
Yeah, I totally buy your point, Yannick. I think, I mean, technology can be, can help to have a different way and different thinking of learning, where, as I said before, you can learn simply using commodity headset at home anytime you want. And I think for everybody, because that's another big issue. I mean, we have done this project in the AT manufacturing. And as you know, manufacturing is a field where very few women are working. I mean, the percentage of students, female students that are starting a career in this direction, as well as already workers in that field, is very, very low. And sometimes it is a prejudice, of course, but also sometimes they get scared to enter this field that is traditionally male oriented. So the possibility to do this learning in a virtual reality, in an environment where you still feel comfortable, can also be a huge support for them. So I think that the next step. I think that.
True. Okay, now and I remember what I actually wanted to say. The point was happiness of learners, or happiness of employees. I mean, learning is a long-term investment, and it might be there might be in a return in a couple of years, but in fact, it's always the happiness of employees. What I often heard when I talk to colleagues or friends or whatsoever is that an employer or company is attractive because they yield the opportunity for education for future projects or for future ideas.
Well, thank you both. It was very interesting to hear both perspectives, and also thank you, Sylvia, for stressing this thing, the topic about women that are not being many in the manufacturing sector. Unfortunately, this is true. And then how to attract more women in the manufacturing sector. This is another question, quite extensive. Okay, I see that the time is almost up, but I would like to quickly ask you one more question, the last one to both of you. From your perspective, what are the major obstacles on the job training and immersive training? Is it mainly because of the high cost of training for companies, or of lack of awareness, or both? Or there are some other also obstacles?
I see a lack of awareness, and I also see a lack of opportunities. So, for example, by either work integrated learning or by work connected learning, for example, by the idea that Sylvia just presented.
Yeah, and if I can add on that, you know that Europe is mainly SME based. So I would say you need a really target learning. I mean, apart from something very basic that can be general, like a course on artificial intelligence or something like that, if you, for example, are using a specific machinery in your company, you need to be trained for this machinery. And if you I mean, if you are the producer of the machinery and have to send someone to the company where people have to learn the things, of course, this is a very high cost. And therefore, I think there is somehow the idea, okay, there are manuals, I can read them, I can try to do it without having real training on that, I can arrange myself. While I think it's very important to have specific training because the specific training is something that gives you confidence with the machinery. And therefore, to have something on virtual reality allows you, for example, if you have a new version of the machinery, just to put some modification to the training and then have it again for a very low price. And also in virtual reality, you can do maintenance, collaborative maintenance, without having to move the person from the producer to the user. I mean, there are really huge advantages in terms of cost, because training, I fully agree that awareness is probably the top element, but cost is really very important, especially for the landscape, the SME landscape we have in Europe.
Yes, that is true. Especially for SMEs, it's sometimes can be quite hard to apply, especially this new technology of VR, virtual reality training. So to wrap up quickly all what we discussed. So thank you very much for your presentations and for this very fruitful discussion about the complex and dangerous machinery for the future industry, about the digital interaction between human and machinery, about the machine learning applications, and the cognitive systems in implementing the machine learning. It was very interesting to hear, to have these insights about and get into more details about the virtual reality applications, the on-the-job training, how it works, what are the advantages, and how companies can apply this training in their working environment. All right. So again, thank you very much for being here with us. Of course, if you will have any other questions, you can always contact us. Also, the audience will be able to contact with our guest speakers. So, all right. I believe we can close the webinar now.
Thank you very much.
Thanks a lot again. Right. Thank you very much, and I wish you a nice day.
Thank you. Also from my side.
Thank you, everybody. Bye-bye.
Bye-bye.